Okay, so for this problem, I'm going to start by identifying what the problem's asking. An 11.5 milliliter sample of liquid butane with a density of 0.573 grams per milliliter is evaporated in an otherwise empty container at a temperature of 28.5 degrees Celsius. The pressure in the container following evaporation is 892 torr. What is the volume of the container? So I'm going to start by underlining all the given information. Next, I want to find out what they're asking me to solve for, which is volume. So with these types of gas problems, you're going to want to convert everything into Kelvin and ATMs. So to start off, I'll start by converting 28.5 degrees Celsius to Kelvin. And the conversion factor is you just add 273. And you're going to get 301.5 Kelvin. Next, I'm going to convert 892 torrs to ATM. And the conversion factor is 1 ATM over 760 torr. Whoops. Giving you 1.17 ATM. Now, from here, what you want to do is find out the molar mass of liquid butane. So the formula for liquid butane is C4H10. Oops. And then so carbon has a molar mass of 12, and since there's 4 carbon, it would be 12 times 4, which is 48. And hydrogen has a molar mass of like 1.008, but I'm just going to use 1. So 1 times 10 is 10. Then you add it together, and then you get 58. So 58 would be the molar mass of liquid butane. And then from here, with your number 58, what you want to do next would be convert the given sample, the volume of it, using the density. So what this would look like is 0.573 grams per 1 ml equal, and then it says you're given an 11.5 milliliter sample. So I'm just gonna write 11.5 ml. And then we want to find out the amount in grams. So we're just going to be solving for x. And then to solve, you would just multiply both sides by 11.5. And then you're going to get 6.59 equals x. So this number represents the amount in grams of an 11.5 milliliter sample of liquid butane. You want to convert this number into moles so that you can use the formula PV equals nRT. And the reason why is because you're asked to find the volume, and we're given temperature, pressure, and also N, which represents moles. And the way we get moles is by converting this amount of grams, 6.59, to moles. And then we have the three variables that we need in order to solve for the fourth variable. So the way that I'm going to convert 6.59 grams is using stoichiometry. So 6.59 times, and then earlier on I found this number, so write grams per mole to make that clear. This is a molar mass of liquid butane, so 1 mole is 58 grams. And then these grams would cancel, and then 6.59 divided by 58 gives you 0.0114. So now you have your amount in moles of liquid butane. So now we're going to use PV and RT, just plug in all the variables, and then it'll give us our answer. So our pressure that we found is going to be, actually, I want to isolate V first. So we're making it easier on ourselves. All right, this is a formula we're going to plug everything into. So then it's going to be N, we found out to be 0.114 moles. R is a constant, and the value of it is 0.08206 liters times times ATM divided by Kelvin times mole. And then temperature we found to be 301.5 Kelvin. And then our pressure we found to be 1.17 atm. So here we just plug into our calculator all the numbers and solve, and notice that all the units cancel except for liters, which is what we want. And then once you solve, you get that your volume is 2.41 liters. All right. Thank you, class. Hope you enjoyed.